Good morning, students. So we're going to start a new chapter today, that is measures of dispersion. Okay, so let's start measures of dispersion. Now, first we'll have to understand what is dispersion, and then we will go on and understand what are the measures that we are supposed to take for such dispersions to solve. Okay, so let's see what is a dispersion and how do we take the measures. Excuse me. Now, the definition of measures of dispersion is given by Kafka. The author says, the measurement of the scatterness of the mass of figures in a series about an average is called measures of variation or dispersion. Now, let's take, for example, now few students from the class are there very nearby to the college. Okay, you stay in and around, very nearby to the college. Around the college only you will be staying, so it will be a walkable distance for you to reach the college. So you people are very close by. Then there are few students who will have to take bus to travel to the college, or they will have to come in some personal vehicle, or somebody will drop them. So they are not too close to the college, but they have certain distance. They live in a certain distance from the college. Now these students who live in the distance from the college, that is called dispersion. Means they have scattered themselves a little far away from the actual place. Okay, so your actual intention is to attend the college which is there in a particular place, but your house is being scattered, or it has been a little far away. Like this, if you take many students, they will have houses in a little further places. Now say, suppose here is the college and there are few houses which are very close by to the college. Now these are not dispersion, but if you have houses a little further away, now you see few students who are staying further away like this, so these are dispersion. This scatterness of the mass of figures of the series. Now here I took an example of students. Now if the same thing happens with number, now let's understand with number. This college will become your mean. Mean is nothing but your x bar. So the normal college will become your mean, that is x bar, and the numbers which are nearby the mean, they are not too much of dispersion. Okay, say suppose if mean is 10, if mean is 10, then 3, 4, 5, 6, 9, 7, all these are nearby numbers, and there is not much difference with these numbers. But suppose if the series has the numbers, like if the mean is 10 and the series of the numbers are 30, 20, 50, 60, 90, if you have numbers like this, then there is quite a distance from one number to another. So this is called dispersion. So we are dispersing, or we are scattering the mass of figures in the series about an average. We keep that average in mind and we scatter the numbers. So this is dispersion. Now let's understand another definition of the dispersion. That is, measure of dispersion are also called as averages. They are also known as what? Averages. Okay, so these averages of the second order. Now averages of first order will be your normal arithmetic mean. So averages of first order will be your normal arithmetic mean. But measures of dispersion or averages of second order. Okay, for the reason that these measures given in even an average of difference of various items. So we are going to understand this average of second order in the problems. Now once again, let's understand, or let's see what is the definition of measures of dispersion. Now it is the measurement of scatterness. We are going to calculate how scattered or how far are these numbers from the mean. Now if you see these numbers like 30, 20, 50, 60, 90, how far are these numbers from 10, which is the mean? Okay, so this is a measure of variation or dispersion. Now, if you understand measure of dispersion by word itself, dispersion means dispersing, means you are leaving from some particular system and being free. Okay, so that is dispersion. You're there everywhere. So that dispersion value we are going to calculate. Okay, so that is measures of dispersion. So hope everybody understood the meaning or the definition of measures of dispersion. Anybody has any doubt in this, please leave it in the chat. Okay, so let's go on and understand the next point, methods of studying these dispersion. So we understood what is dispersion and what is the measure of dispersion. Now let's understand what are the methods that are there to study such variation. Now why are they staying far? Why there is the difference in the number? With the mean, why there is the difference in the number? So those differences can be understood by these 5 methods. Which are the 5 methods? First one is range, then you have interquartile range, then you have quartile deviation continued with that, then mean deviation, standard deviation, and Lorentz curve. So this is the graphical method. Rest all the 4 methods you will have a problems to be solved. So first is the range, then interquartile range and quartile deviation. You have mean deviation, standard deviation, and Lorentz curve. Please understand these concepts very, very well, because this chapter consists of majority of the marks in your examination for both BCom as well as BBA. Okay, so let's go on and understand what is range. So range is one of the simplest form of measure of dispersion. Okay, so let's understand what is range. So range is the simplest measure of dispersion. So when you arrange the data, when they give you some numbers, let's say where they are giving you numbers from 1 to 10. Okay, between the numbers you have 1 to 10. So you have 2, you have 4, all even numbers they are giving, 6, 8, and 10. You have these 5 numbers given to you. So a range is a very simple measure. So what do we do in range? We just take the highest value. So which is the highest value here? 10 will be the highest value. And we subtract this from the lowest value or the smallest value of the given data, that is 2. So we are going to take the highest value, which is 10, and we are going to subtract that from the smallest value of the data, which is 2. So your range is going to be 10 minus 2, which is 8. So which means this data set of 2, 4, 6, 8, and 10 has a range of 8. So that is what they're talking here. So let's read the second point. When the data are arranged in an order, the difference between the largest value and the smallest value in the arranged group is called a range. Okay, so what is range? It is the it's a difference between largest value and smallest value of the arranged group. Okay, so that is called the range. Now, before we go to problems, we have one small concept to understand. So let's understand that concept and then go for the problems. Okay, so let's go on and check what is that concept. Now, in measures of dispersion, you will have something called absolute and relative measure of dispersion. So this is a little basic topic. Okay, so let's understand what is this. So dispersion can be measured in 2 ways. Okay, we can measure the dispersion in 2 ways. It's something like a measuring a cloth. You can measure the cloth in meters. You can measure the cloth in centimeters. Like that, you have 2 ways here. So what are those two ways? First, absolute and then relative. So what is absolute? I have a particular value to give. So how do I measure milk? I measure milk in liters. Okay. How do I measure rice? I measure rice in kgs. I measure sugar in kgs. So here I have particular unit to talk about. So if I'm talking about uh, rice, let's say one family consumes 10 kgs of rice per day. Now I only told one family, so that family may have 10 people, 12 people also. So all together they're consuming 10 kgs of rice. So it's a bigger family and particular unit of kgs is being given. So that is absolute measure. They give the data in the original form. Okay, that is called absolute measure. So let's read this second point here, that is the definition. Absolute measure of dispersion is absolute measure of dispersion are expressed in the same statistical unit. So if you see, it is in the same statistical unit. We don't change anything here. Same statistical unit in which the original data is given. Rice is being measured in kgs and sugar is measured in kgs, water in liters, milk in liters, sometimes in your rice, dal, everything in quintals or bags. Original data is given directly. Okay, so these values may be useful in comparing. So why do we use absolute measure? Because we have to compare. When we compare, we'll get lot of other information. So that is why it is useful in comparing the variation of two distributions which are expressed in the same unit. For example, rupees. Now money is given in the form of rupees. 1 rupee, 2 rupee, gone are those days of 50 paisa. Paisa is not available now. So you have 1 rupee, 2 rupee, 3 rupee, 10, 15. Now this everything, even if you take 100,000, the lakhs, crore, then million, everything at the end says rupees. So rupees, the currency is the original value. Then kgs, all of the quantities can be given in kgs. Quintals, if you have too much of kgs, then you can take it as quintals. So but original value is given, that is called absolute measure. Then relative measure. So we understood what is absolute measure. Now let's understand what is relative measure. Now relative measure is not given as original data. Now what they do in relative measure? They give you the ratio of the measure. Ratio of the measure means, for example, I say now BCom for first internal test. Okay, the whole class performance was much better. Let's say they were 20% better than BBA. If I give a example, if I give a data saying BCom performed 20% better than BBA in first internal test for statistic subjects. So I'm giving statistic subject, but I'm saying BCom, I'm saying BBA. But I am not expressing the marks properly. I'm giving it in a ratio. I say 20%. Now 20%, if I say, you will have to sit and calculate what is the actual marks. So that is relative measure. You don't give the proper information or exact information. You give it in the form of ratio. Ratio or percentage. Okay. Ratio of measure of absolute dispersion to an average. Now this relative measure of dispersion is called as coefficient of dispersion. So in every problem throughout the chapter, we are going to solve the particular problem. Let's take, for example, range. Now I just now explained range. Range is the difference between the largest value and the smallest value of the given data when it is in arranged form. Now after that, after calculating the range, then I will have to calculate coefficient of dispersion. So coefficient of range I will have to calculate. So every time you calculate a data, you will also have to calculate the coefficient of the particular data. So which means we are giving two information, two proper information for the taking from the problem. What is that? One information we take the actual data and solve the problem. The second information, we are going to express that result in the form of ratio. Now, when we express that in the form of ratio, it is called as coefficient. Okay, so coefficient of dispersion. Dispersion is a general term. Now, if you are calculating range, it will be coefficient of range. If you're calculating mean deviation, coefficient of mean deviation. Quartile deviation, coefficient of quartile deviation. Like this, you're going to solve the actual mean deviation, quartile deviation and range, and also solve coefficient of those dispersion values. Okay, so hope everybody understood the absolute measure and relative measure, because everywhere you will have formulas separately for absolute measure as well as relative measure. Okay, so once again, absolute measure means particularly they will give you the units, and you have the original data which is being used or utilized here. If you comes to relative measure, then you have a ratio being expressed from the original data. They don't give the original data, they only give in the percentage or the ratio form. Okay, so everybody understood the slide, absolute and relative measure? If so, please leave it in your chat. Okay, so let's go to range once again. Now, range. In range, I already told it is the very, very simplest form. It is the very, very simplest form of measure of dispersion. So in the simplest form, what are we going to do? We are going to find out the difference between the largest value and the smallest value. So we're going to find out the difference between the largest value and the smallest value in the arranged group. And this range, this is the range in terms of absolute measure. Now, what is absolute measure? Once again, absolute measure is when you have the original data to be given and utilized. That is called absolute measure. So what is the formula for range under absolute measure? So let's see the formula for range under absolute measure. That's very, very simple. The range is equal to L minus S. So L is equal to largest value, S is equal to smallest value. So L minus S will be the range under what? Under absolute measure. So firstly, original data we take, we solve, that is absolute measure. Under that, the formula is L minus S. Okay, so now after understanding absolute measure, we also have to understand the relative measure. So let's see what is the formula under relative measure. Once you see relative, it has to flash to you. Relative measure means coefficient of dispersion. So let's see under relative measure, what is that formula? So under relative method means it is coefficient of range. Okay, so coefficient of range is equal to absolute range divided by sum of two extremes. So first of all, what are the extremes? Lowest value, largest value and the smallest value. Largest value and the smallest value are the extremes. So I gave an example of 2, 4, 6, 8 and 10. Now in these, if you see, this is the smallest value, this is the largest value, which is two extremes. So sum of two extremes means largest value minus smallest value, largest value plus smallest value. Absolute range is your normal range formula, L minus S. Absolute range is your normal range formula, L minus S, divided by sum of two extremes is L plus S. That means the formula for coefficient of range goes like this. That is L minus S divided by L plus S. So if you have a series given and if you know what is the largest and smallest value, you can easily find out the range. Okay, so hope everybody understood the formulas also, both the formulas. Please leave it in the chat if anybody has any doubt regarding the formula. That's nice. So everybody understood the formulas. So let's go on and calculate the problems now. So let's start with the problems. First problem. So everywhere throughout the statistics, we have seen three types of data. One is individual data, discrete data, continuous data. So here also that will continue. For first, we are computing range for individual observations. So we are computing range for individual observations. Okay, so let's read the question. Find the range and its coefficient from the following data. And they have given us rupees 200, 250, 222, 275, 288, 230. So these are the numbers given to us. There are no frequencies given. There is none other table provided to us. So that is when we will be able to understand this is an individual observation. Individually, the numbers are present here. Okay. So now in this series, let us check which is the largest value. Now, if you see 200, 250, 222, 275, 280, 230. So by observation, you can say 280 is the largest number. And now, after finding largest number, let's find out which is the smallest number. Now, again, by observation, you can easily say 200 is the smallest number, right? So we understood there is one largest number and there is one smallest number in the given series. Now, let's go on and calculate the range for this. Now, range, the formula is L minus S. So, largest minus smallest number, which is equal to 280 minus 200. 280 minus 200 is equal to 80. Okay, so that is how we find out range. So it is largest value 280 minus 200, the smallest value is equal to 80. So the range for this series is 80. Okay, now this was for your absolute method. Absolute measure, we found out the range. Now we'll also have to find out for relative measure or relative dispersion. Now once it is relative, it means it is coefficient. We also have to find out coefficient of range. Now here the formula for coefficient of range is L minus S divided by L plus S. Okay, it's L minus S, the absolute range, the normal formula of range divided by L plus S, that is sum of two extremes. So what is L minus S? We already know what is the largest number and we already know what is the smallest number. So the largest number is 280 minus smallest number is 200. So that is your absolute range here above. Then below that 280 plus 200. Okay, so largest number plus smallest number, that is sum of two extremes. If you see the calculation, 280 minus 200 will be 80. 280 plus 200 will be 480. So if you see the calculation again, it is 80 divided by 480, which is equal to 0.166. So the coefficient of range under absolute measure or the ratio way of giving the measurement for coefficient is 0.166. So this is how we calculate a range for individual series. Okay, so what did we do to summarize this problem? What did we do in the whole problem is we calculated the largest value, which is 280. We calculated the smallest value, which is 200, and then we applied the formula of range, that is L minus S, and then we found the coefficient also. Okay, so hope everybody understood the problem. Okay, that's nice. So everybody understood the problem here. Now, once we are done with this problem, now let's go on and understand the next problem. Okay. Now, second problem. Compute the range and the coefficient of range in the series and state which series is more dispersed, which series is more uniform. So here, along with computation of series, they have also asked us which is more dispersed or which is more scattered. I told you, more students who stay far away from the college, they are more dispersed. Students who stay near the college, they are uniform. So we also have to analyze which series is more dispersed and which series is more uniform. Okay, so let's go on and see the problem, that is series. Series, they have given us three series, A, B and C, and there are certain numbers given to us. Okay, this is not a discrete series problem, it is still an individual. How do you know it is an individual? You see three different series and individual observations of all of it are given. Okay, so this is an individual series problem, it is not discrete. So we are going to solve this problem here first. First, let's solve this problem and understand which is more dispersed or uniform. Okay, so for all the three series, I've solved it together here. So let's see. First, I've written the formula. I've written the formula for range, which is L minus S. Then I've also written the coefficient of range formula, that is relative method, L minus S divided by L plus S. Now let's see under series A how to calculate the range. Now before we see this, let's go back to the question and analyze what all are the largest and the smallest number. Okay, so for first series A, let's see what is the largest number. Now if you see series A, that is this, only this complete series, if you see it here. So what do you think is the largest number? You can see 12 as largest number. So 12 can be taken as largest number. And if you see the smallest number, 4 can be taken as smallest number. Okay, so for series A, 12 is largest number, 4 is smallest number. So what we will do is, let's go back to the solution and solve for series A. That is largest number 12, that is what we calculated there, largest number 12 and smallest number 4. So L minus S, 12 minus 4 is 8. Now once you know L and S value, it is easy to find out coefficient of range. So you have 12, 12 minus 4 directly taken, then again 12 plus 4. So how much do you get? 8 divided by 16, which is equal to 0.5. So the coefficient of range for series A is 0.5. Okay, next. That was for series A. So hope everybody understood series A. Now let's solve for series B and series C also. So let's go and again analyze what is the largest and the smallest number for series B and series C. Okay, so now for series B, that is the second line here, or the second series given here. Series B, what is the largest number? The largest number is 13. 13 is the largest number, and the smallest number is 4 again. Okay, so for B, 13 is the largest number and 4 is the smallest number. Now let's go back and solve this for series B. Let's solve the range. Now for series B, when you're solving the range again, so range, largest number 13 minus smallest number 4. So range is 9. Coefficient of range 13 minus 4 divided by 13 plus 4, which is equal to 9 by 7, which is 0.29. Okay, here it was 0.5 exact. So you have 0.529 for series B. So that is how you find range and coefficient of range for series B. Now again, as usual, let's go back and understand for series C. Now for series C, this last line which is given to us here, that is 1, 8, 9, 18, 12 and 2. So this is the last series given to us, which is going to be, the largest number will be 18. The largest number is going to be 18 and the smallest number is going to be 1. So we have largest number being 18 and the smallest number being 1. Okay, so here we are going to take these numbers again and we will solve it for C, range C. Okay, so here if you see range 18 minus 1, which is equal to 17. Then similarly, we'll have to find coefficient 18 minus 1 divided by 18 plus 1. So that is your range. Now when you calculate this value, you get 0.894. Okay, you get 0.894 here. So this are the values of series, the range and the coefficient of range. So these are the values. Okay, so hope everybody understood until here. Anybody has doubt until here? Please leave it in the chat. Did everybody understand? Okay, so throughout the problem, what we did was we just analyzed which is the highest value of the series, which is the lowest value of the series, and we subtracted them. So for series A, for every question here, for series A, what is the highest value and the lowest value, and we calculated. For series B, again highest value and lowest value, and we calculated. Again for series C, highest and lowest, we calculated the range. So how did we calculate range? The formula goes L minus S. And then how did we calculate coefficient of range? L minus S, range divided by L plus S. That is sum of two extremes. So the same thing we did for all the three series. Now, apart from this, they have asked us to calculate. If you see the question once again, they have asked us to analyze and calculate. What have they told us is, state which series is more dispersed and which series is more uniform. So we're going to give the conclusion for this based on these things. Okay, so let's see how to give the conclusion. Now, once you have calculated the range and coefficient of range, now see the coefficients here: 0.5, 0.529, 0.894. So out of three coefficients that you calculated, so which is high in value? 0.894 is more in value for the coefficient. So what we are going to say from this is 0.894, which means series C is more dispersed, means it is more scattered around. So series C with more coefficient value is scattered around. Okay, understood? So that is where series C is more dispersed. Now another coefficient value for us is series A, which is lowest, that is 0.5. So 0.5 is lowest out of 3, and so series A is more uniform. Okay, series A is more uniform, but series C is more what? Dispersed. So series C is more scattered. They're scattered more, and series A is more uniform. They are very nearby to each other. So how do you understand, or how do you come to conclusion which is dispersed or which is uniform? By seeing their coefficient. So I've given a note at the end that lesser the coefficient measures, more the uniformity. So if you see, lesser the coefficient, 0.5 is less, so more uniform. Higher the coefficient measures, less the uniformity. So 0.894 was higher value. So that is why it is less uniform and it is more dispersed. It is less uniform and it is more dispersed. So that is why you will have these problems where you are supposed to give the conclusion properly throughout. You are supposed to give what? Conclusions properly throughout the problem. Okay, so hope everybody understood this problem. Both the problems are only for your individual series. We have not done discrete or continuous series here. It's only for individual series. Anybody has any doubt? Everybody understood the problem? Please leave it in the chat. Okay, that's nice. Everybody's saying they've understood the problem. Okay, so after this, we have the next problem, which is going to be discrete series. Now, again in discrete series, let's see the problem. Now, discrete series, from the following data, compute the range and its coefficient. Now, computation of range and its coefficient as usual. But how do you know it is discrete series? You have X, you have F given. So that is why you can say it as discrete series. Formula remains same. Coefficient of range formula also remains same. But the only thing you have to notice, you have to consider variables only. You need not consider frequencies. Frequencies are not to be considered. Okay, it is only your variables and it is not frequencies. So if you consider variables, check 10 is the smallest number, 80 is the largest number. Okay, 10 is the smallest number, 80 is the largest number. So if you take range, it says 80 minus 10, which is equal to 70. So how do you find range? The largest number minus smallest number, 80 minus 10, which is equal to 70. Again, how to find coefficient of range? L minus S divided by L plus S, which is equal to 80 minus 10. 80 minus 10 divided by 80 plus 10, which is equal to 70 by 90. 80 minus 10, how? Largest minus smallest. 80 plus 10, again how? Largest plus smallest. So 70 divided by 90, the coefficient of range is 0.7777. So this is given in the form of ratio, that is 0.7777. So for discrete series, you're supposed to only consider X and don't consider the frequency. Only taking from a frequency, only considering from X, you have to take the smallest number and the largest number and calculate range and coefficient of range. Okay, so hope everybody understood discrete series also. Anybody has doubt in discrete series? Okay, that's great. So we'll stop here with discrete series. Continuous series will be done in the next lecture. Okay. Yeah. Thank you, students.